Hello, young math Padawans. It's Mrs. Angel with a quick lesson for today on the parts of a parabola. So let's first start with what a parabola actually is. A parabola is the set of solutions to a quadratic function, and this is the next function that we're going to be learning about. You know that a function is going to be quadratic if you are at some point or another squaring the inputs. So the fact that you will eventually square something tells you that that function is going to be a quadratic function. And later on, we'll get into why that is. For now, let's just talk about the parts of this parabola. So the parabola, like we said, is the set of solutions to a function, and it forms kind of this U shape, or sometimes it'll be the other way around, kind of like a rainbow. So every single point on this parabola is a solution to a quadratic function. We're going to start with the most important point on the parabola. Now down here is a point that is unique on this graph because this is the only point on the graph that is not reflected on either side of the parabola. This point is called the vertex. Another reason why the vertex is unique is because it's always going to be the maximum or minimum point of the parabola, depending on which way the parabola is facing. So if I were to trace down from left to right, my parabola is decreasing. I hit the vertex, change direction, and now it is increasing. And all of my solution points are above this vertex. So for this particular parabola, because the vertex is the lowest point on our graph, we would say that this vertex is a minimum. And the coordinates of this vertex are where x is 1 and y is -4. So we're just going to come down here and label that. The vertex is where x is 1 and y is -4. Now you might notice that running through the middle of the vertex is this invisible dotted vertical line here. And there's a reason why this line is going through the middle of the vertex. This line is chopping the parabola in half. Every single section on this side of the parabola is equally reflected on the other side, as is every single point on either side of this line. This line is called the axis of symmetry. The reason why this is called the axis of symmetry is because to be symmetrical means to be the same on both sides. Think of like a butterfly is symmetrical on either side of its body. The axis of symmetry is always going to be a vertical line, so the formula for the axis of symmetry is always in the form of x equals, and then whatever the x value of the vertex is, that's also going to be the x value of your axis of symmetry. Because if we zoom out here, the vertex is sitting on the axis of symmetry. So this axis of symmetry has an equation of x equals 1, because that's the x value of the vertex. So our axis of symmetry here is x equals 1. The next part of our parabola here that we're going to look at are these 2 points where the parabola is crossing the x-axis. So it crosses the x-axis going down, turns around at the vertex, and then crosses the x-axis again, going the opposite way. These are called the parabola's zeros. So the reason why these are called the zeros of the parabola is because these are the inputs x that produce an output of 0. So if I look at the coordinates here, one of the zeros is at -1, 0, and the other one is at +3, 0. Hence why these are called the zeros of the function. So down here at the bottom, we'll label those as -1, 0 and 3, 0. The final part of this parabola is the point where it is crossing the y-axis. We actually already know the name for that. This point right here is called the y-intercept. And you might recall that from when we studied linear functions. So the y-intercept is at 0, -3. 0, -3. All right, so now we have labeled all parts of this parabola from its vertex, axis of symmetry, to its zeros and its y-intercepts. Let's look at our second example. Here we have a parabola that is reflected, meaning instead of going up like a U, this is going down like a rainbow or an upside down U. But just as in the previous example, we can still label all of the different parts. Let's start by labeling the vertex. So here's our vertex where the parabola changes direction. And in this case, our vertex would be considered a maximum value. The reason why this is a maximum value is because it is at the very top of our parabola. Every other solution point is below it. Down at the bottom here, let's write down the coordinates. It looks like this vertex is at 1 and 4. When x is 1, y is 4. Up next, let's go ahead and identify the axis of symmetry that is cutting this parabola directly in half. So this is called our axis of symmetry. Remember, it's always going to be whatever the x value of the vertex is. So it's basically telling you what the input for the vertex was. This is crossing where x is 1. It looks like it is crossing the x-axis in 2 spots. These again are called the zeros of the function, and there are 2 of them because there are 2 inputs that produce an output of 0. They are -1, 0 and 3, 0. And finally, our point that is crossing the y-axis here, that is our y-intercept. And that is at the point 0, 3. That concludes today's mini lesson. I will see you next time.